Good morning, everybody. Hopefully you're doing well today. If we could start with some green check marks so I know you are with me, everything's working, and then we will just jump right into the material for today. And this is kind of like a big moment in the class. This is really the last sort of new topic I'm going to discuss. This is it. Everything we're going to cover, we've covered. So kind of an interesting place to be in the course. Now, assuming you're all cut up and ready to go, everything that's been kind of delivered to you is now done, and it's kind of up to you guys to review. I mean, we're going to do some things and look at some provincial exams and other things like that, and I'll make sure our review goes well, but yeah, that's kind of it. It's crazy. Perfect. So we've got lots of green checks, which is good. And I left us with a few questions in the sine and cosine section of your learning guide. So yesterday I gave you a little bit of time to go through that. Was there anything from the first, I guess it was 4 pages I said, anything from the first 4 pages? I did a few and I asked you guys if you wouldn't mind doing a few. Anything you didn't really understand or wanted some more clarification with, I'd be happy to go through that. And if not, I will just do a few problems in the next section. Page 211A, I like that. So given the following information, find the unknown side. You know what, Alex? I was sitting in my office working hard with really important things, and then I thought, oh, I forgot to look up Kleinbottle, and then somebody came into my office or something kind of distracted me. I did actually think about it though. Maybe tomorrow I might have some more information on Kleinbottles. All right, what we need to do is figure out the angle we're dealing with. So in the question we have one angle in the corner here, a 60-degree angle. We're going to label all of our sides based on that angle. I see that the longest side is my hypotenuse. If I were to draw a dotted line across here, this would be the opposite side. And that leaves the bottom here is the adjacent side, and the adjacent side forms the angle with the hypotenuse. There we go. What do I need? What do I know? Well, the question asked me to find the opposite side, because that was the unknown. I know the adjacent side is 8, so I have the opposite and the adjacent. So I think back to SOHCAHTOA, and I have the opposite and the adjacent. So that turns out to be opposite and adjacent. So we're using the tangent ratio. So I'm going to take the tangent of my angle, theta we'll call it for now, as the opposite side. I guess I could write down opposite divided by the adjacent. In this case, theta, the angle I'm dealing with down here is 60 degrees. So I'm going to put in 60 degrees. The opposite is x, and the adjacent is 8. Now I need to get x by itself. It's a little algebra. Multiply both sides by 8. The 8 divides out to give me a 1 on the right. And then all I'm plugging into my calculator is 8 times the tangent of 60 degrees. And I'm going to have to do that. So 8 times the tangent, 63. I get 15.7. is the length of x. Now I don't have any units, else I'd include them, but there you go. So that was number 11A. How big is a proton? Small. I think a proton is 1.67 times 10 to the negative 27 kilograms. So that is a 1 with 27 zeros in front of it, kilograms. off the top of my head. Somebody might have to look that up. I'm not sure if that's right or not, but there you go. That's how big a proton is, Alex. Small. Okay, that was it for the sine-cosine ratio. One interesting thing about this whole unit is we go through the tangent ratio, then the sine ratio, and the cosine ratio, and then when you get to the end, the last section, everything just kind of gets thrown away and you say, okay, here's a triangle, find the missing sides or angles, and then you need to actually just figure out which trig function you're going to use, and it changes for each question depending on the information you're given or trying to find. So if we look at, this is on page 5, using trigonometry, calculate the value of x rounded to 1 decimal place. Looking at number 3. So in this question, we're not told to use tangent, sine, cosine. It just says find x. So you need to go and look at some of the information you're given. This looks exactly the same as the question I just did. Is it not identical? X, 8, yes, it is identical. There you go. Those are all probably the same. Let's look at D. So this is on the top of page 6. Again, the triangle's been rotated a little bit. Doesn't really change the question. It just kind of, you know, it's rotated. You could turn it and redraw it if you wanted. That's fine. Shouldn't matter. What angle am I given? I have this 42-degree angle down here at the bottom. So that's the angle, my reference angle. Everything's going to be measured from that angle. When I say everything is going to be measured, I mean all of my sides are going to be labeled. First thing I'm going to do is find my hypotenuse, because that is the longest side. Bet you guys are tired of me saying that. If I started at my angle here, this 42, and I go straight across, that would be the opposite side. And then, of course, I also have the adjacent side, which forms the angle I'm dealing with the hypotenuse. Back to this old game. What do I have? What am I trying to find? Well, the question told me to find the value of x. So there's x. I don't know the adjacent, and I'm not trying to find it, so I can just get rid of it. Not interested in it right now. I also have this opposite side of 6. So we go to SOHCAHTOA. What am I dealing with? Opposite and hypotenuse. Which 3 of my trig functions has the opposite and the hypotenuse? That is going to be the sine. So the sine of my angle is the length of the opposite side divided by the length of the hypotenuse. In this case, my angle is 42 degrees. And the opposite side is 6, and the hypotenuse is x. Now, you guys hopefully have gone through all of the questions in the learning guide. One thing that's kind of interesting that happens when you solve lots and lots and lots and lots of these type of questions, you'll notice when you have your variable that you're trying to find on the bottom, it eventually works its way over here. And I don't know if anyone's noticed this, but whatever's on the other side just goes to the bottom. It just kind of, they switch places. Now there's a few mathematical steps along the way, but after you've done a bunch of them, you'll just notice that this happens, and you can kind of, you know, just jump right to that step. If you're feeling lucky, I will, of course, show some steps along the way. So maybe over on the side here, I'll just rewrite it. Sine of 42 degrees is 6 over x. Multiply both sides by x, because that's going to divide out on the right and move it to the top on the left. So now I have x times the sine, 42 degrees is equal to 6. I divide both sides by the sine of 42 to get x by itself. And you'll notice that we've ended up at kind of the same spot with both these. So the x just switches places with that 42. I'm going to just plug this into my calculator. 6 divided by the sine of 42 degrees. And we'll see what we get. So we get 8.966. We'll go 8.97. Same over here, 8.97. So that is just an example of a triangle that has a missing side or angle, and we just kind of go and try to find it. Those are probably a little bit more straightforward than some of the later questions here. So I'm going to just scroll down a little ways. 1 decimal place, nearest degree. Let's look at number 7. The wording of this question says solve the following triangle. Now, when a question says solve the following triangle, that means find all of the sides and all of the angles. So I'm just reading your question here, Abby. It says round to 1 decimal place. Could you please show how to do that for D? Sure. 1 decimal place. So if we want to round to 1 decimal place, we had this x is equal to 8.97. We're rounding to the decimal place here. So this 7 means I have to round this up to a 10. So if I carry the 1 with the 8, I'm going to get x is equal to 9.0. So I know it doesn't maybe make a ton of sense, but if we have to round this up and then we have to round the next one up, so just kind of domino effects up the old place value until, and then of course we just leave a 0 for the decimal because it turned into a 10 and that 0 is kind of represented there. What did I say? Number 7. Solve the following triangle, answer side lengths rounded to 1 decimal place and all angles to the nearest degree. So you may see this on a test. It's not as likely on a multiple choice because it's not just going to say solve a triangle, because it's going to ask for a specific side or a specific angle, but it's kind of good practice. Now, one interesting thing about number 7 is when we have a right angle triangle and we're given 2 of the 3 sides, is there a way to find that third side without using any of our trig ratios? Could we find that third side without trig? And how do we do that? Does anyone remember? Or we could use trig if we wanted to figure it out. That's fine as well. Just a couple of steps. To find a missing side of a right triangle, we have I have a feeling somebody's going to put it in a chat. I'm going to ruin their thunder. The Pythagorean theorem. A squared plus b squared is c squared. It just won't go away. We used it back in the very first unit we did, unit number 2, to find like slant heights of right triangles. It's back. So remember, the only thing important about the Pythagorean theorem is that the longest side goes in for c. So I have this guy, and maybe I'll just call this x because I don't know what it is. So I'm going to go x squared plus 6 squared is 15 squared. X squared plus 36, 15 squared is 225, I believe. Yes, it is. I'm going to subtract 36 on both sides. And I end up with x squared as 189. I need to figure out what just x is, so I take the square root of both sides. Square root of 189. Oh no, I've broken my calculator. All right, back in business. 189, it's 13.7. Does that make sense? The longest side is 15, so I know that my answer has to be smaller than 15. And 13 is pretty close to 15. It looks like it's maybe about double this side, assuming it's drawn roughly to scale. So yeah, I'm happy with that 13.7. It's a good question, Alex. Why do we need to know how to calculate the length of a triangle? Can't we just use a measuring tape if we need to figure out the length? I kid you not, this happened to me this summer. My father-in-law has a big pine tree in his backyard, and he said, hey, can you help me figure out how tall the tree is? And I said, sure. I mean, you could probably climb a tree at the top. It gets kind of flimsy. You'd probably fall. It was, about 70 feet tall. So maybe measuring it wouldn't have been the best option. So what we did is we got a measuring tape and we measured away from the base, went right from the backyard all the way to the front yard. So we got a long ways away. And then I stood there and I printed off an inclinometer from the internet. So I measured the angle looking from the ground where the measuring tape was to the top of the tree. And then I used some trigs. So, I had the angle and I had the adjacent side of a triangle. So I was trying to find the opposite. So I used the tangent ratio to figure out how tall the tree was. He wanted to get a boom lift in to trim the top of the tree off. So he needed to figure out how tall the tree was to figure out how big of a lift he would need to get it. So it's a way of indirectly calculating things. And it's handy, and especially for longer distances. If you can find an angle and you know something, then you can use trig from there. Can we use the 90-degree angle to do trig? You can't. It's all based on there actually being a 90-degree angle in your triangle. Trees aren't triangles, no. All right, let's draw a tree. Here's a tree. It's a big, tall tree. Here I am, over here. And what we did was we measured the distance from me to the tree. I don't know, let's say it was 100 meters. And then I took an inclinometer and I looked up at the top of the tree and I said, okay, it's 32 degrees. How tall is the tree? So even though the tree isn't a triangle, I made a triangle with my position next to the tree, and I could see how the angle at the top of the tree, and I didn't have to climb the tree. It was a really big tree, and that's how we do her. Back to the question at hand here, number 7. We found the missing side. Now we can find the angles. The key to this type of question is use the information you're given. I just calculated this bottom side to be 13.7, but that could be wrong. I could have made a mistake somewhere. I could have rounded incorrectly. So when I'm finding an angle, let's say we wanted to find the angle A here, I'm not going to use this 13.7 because I don't know if it's right or not. I hope it's right, it looks right, everything about it seems right, but if I use this to find the angle, now I could be sort of compounding my mistake. So I don't want to take an angle from a piece of information I've already calculated when I'm given enough information to find the angle as it is. So I'm trying to find this angle, we'll call it theta. It's a good one to use. If I go across, this is now the opposite side. My longest side is here, is the hypotenuse. So what am I going to do? Well, I have the hypotenuse and I have the opposite. Think about SOHCAHTOA. Opposite hypotenuse. That is the sine. Sine of the angle is the opposite times the hypotenuse. I'm going to take the sine theta, it's the length of the opposite side, divided by the length of the hypotenuse. Okay. I don't know what the angle is, so I'm going to find it. The opposite had a length of 6, the hypotenuse was 15. And because I'm finding the angle, instead of finding the ratio of sides, I need to take the inverse sine of 6 divided by 15. So my calculator is good because I can put brackets in. You may have to do the 6 divided by 15 first to get 0.4, and then take the inverse sign of 0.4. But I'm just going to plug it all in once. 6 divided by 15. I think I got my camera working here today. There we go. So that's what it looks like in my calculator. Inverse sign of 6 divided by 15. And then when I hit equals, I get an angle of 23.57. We'll call it 23.6 degrees. All right, I have a triangle. I have this angle now is 23.6. What about this angle up at the top? How can I calculate this angle? Is there any way I can find it really quickly? There's actually 2 ways to find it. Any ideas? I could do maybe both of them. We'll see how that goes. I know that all the angles in a triangle must add to 180 degrees. So if I have 180 degrees in my triangle in total, I have my right angle, I have 23.6. What am I left with? And really it's just a little bit of subtraction. 180 minus 90 minus 23.6, 66.4. So now I know that angle up in the top is 66.4. Now officially I've solved this triangle. I found all the missing information. I found the missing side, I have the missing angles. I could also have started with the angle up at the top here, angle B. Maybe I'll write it like this, angle B. If I had started the question, didn't know it was anything, and measured my angle from here, I would go across. This would be the opposite side from that angle. This is still the hypotenuse. This is the adjacent. So I could use trig to find it as well. I have the hypotenuse, I have the adjacent. So if I were to take the cosine of my angle, I would have the adjacent side divided by, dyslexia there, ADJ, divided by the hypotenuse. In this case, the adjacent was 6, the hypotenuse was 15. Taking the cosine of that, and then to find the angle, I'm going to take the inverse cos of 6 over 15. Let's see if my subtraction was right. So second cosine, 6 divided by 15, 66.4. So they were both the same. 2 different ways to kind of solve for that missing side or missing angle. How are we doing there? We doing okay? Okay. Question number 8. I just want to set it up for you guys, and then I'll let you guys maybe do it. It's just kind of a different way to write sort of notation. It is exactly what it looks like. This triangle means triangle. EFG is the 3 corners of the triangle. It says angle. I guess I could write this in. This is triangle. This is angle. EF is the side from E to F, and EG is the side. So let's see if we can draw our picture. EFEG. All right, so I know angle G is 90 degrees. Let's go E and F. E to F is 15, and E to G is 13. The question's asking us to find angle EFG. How do I find angle EFG? Well, I start at E, and I go to F, and then I go to G. So what angle am I trying to find? It means I'm trying to find this angle down in the corner, EFG. Start here, and here. So it's just some notation for algebra, or I guess it's not algebra, it's geometry notation. Once you get it set up, it's the same as all the other questions you've seen, but sometimes you'll see it kind of written like that. Just seen your question here, Abby, or sorry, Ava. For question 9 below it, what do we do if we don't have a protractor? Question 9, 7, 8, 9. Use a protractor to measure one of the unknown angles and determine the length of side X. I'm not sure, on your formula sheet, is there a protractor on that sheet? I don't believe there is. Fractions review, unit 2. See if I can find my formula sheet. Does anyone have one on them, near them? I don't know where mine is. No, it's not on there. Thank you, Taylor. How do we do it? You, on a provincial exam, will likely not be asked. Just do your best. If a question on a provincial asks you to use a protractor, just put up your hand and say, hey, I need a protractor, and somebody will get you one. They are allowed on the exam. If you need one, one will be provided for you. At home, if you don't have a protractor, I don't have a protractor with me, so I can't measure it. So unfortunately, there's not much we could do. We could, however, get a ruler out and measure the length of this side. If we could find out the length of X, then we would be okay. So on an exam, you can use the ruler to measure the length of a side, but you aren't given a protractor, so I don't know why that's in there. It's probably a mistake. You just ignore it for now. Holy cow, number 10 is my exact problem I dealt with. Minus, we know how tall the tree is already. So I'll do number 10, and then if you guys have any questions, then we can go for it. So calculate the angle of elevation of the line of sight of a person whose eye is 1.8 meters above the ground, is looking at the top of a tree, which is 27.5 meters away on level ground and 19.4 meters high. All right, so the tricky part of this question is we have our person. Here's our person, and the person's eye, who's measuring it, is 1.8 meters above the ground. So when we are given all this additional information, like the person is 27.5 meters away from the base of the tree, and On level ground, base of the tree on level ground and 19.4 meters high. So the tree is 19.4 meters. So I've drawn a picture and I've included all the information I'm given. The trick is this. When I draw my triangle, so from the person to the base of the tree to the top of the tree, there we go. I have a right angle now. The question's really specific. It says measuring from the person's eye. So even though I have this tree, it's 19.4 meters, I'm not measuring from the bottom of the person, I'm measuring from the person's eye. So I need to measure my triangle up here. So what I'm gonna have to do is, I'm gonna redraw my triangle. So of course this is not drawn to scale. Now, this little red bit here isn't the same length as the full 19.4. The red bit on the side is going to be 19.4 meters minus the 1.8 that the person was standing above, because their eye is 1.8 meters above the ground. So that is the difficult part there. So if I had 19.4 and I subtracted 1.8, I'd end up with 17.6. So my triangle really looks like this. This is 17.6, this is 27.5, and it's asking me to find the angle of elevation, my right angle here. So I'm confident you guys can do that. Alex, all of these questions are coming too early because we're going to talk about atoms in science. So I don't want to ruin the surprise for you when we get there. Or you could just look it up online. So that was 10. I'll let you guys solve that. 11, elevation observed from the base of the building. That's pretty straightforward. I'll do one of these. Maybe one or two of these. The idea behind the last section is that basically you're given a bunch of word problems and you're asked to solve them. Generally speaking, you'll be given 2 triangle problems, like the one I'm about to do. And you always, if you watch the little pre-recorded video, you always have a shared side between your 2 triangles. So you'll be given a bunch of information for one triangle, enough to find a shared side, and then from that shared side you can find the thing you're trying to find. So it's always going to be a couple steps. So if we look at number 12, 2 office towers 75 meters apart. From the 10th floor of the shorter tower, the angle of elevation to the restaurant is 40 degrees. So angle of elevation is measuring up. There's 40. The angle of depression to the base is 32 degrees. Find the height of the restaurant. So we're trying to find the height from the ground to there. Is there a way we can directly measure it? Unfortunately, I don't think there is. Could we do it though in perhaps 2 steps? If we can find out, we have a right angle there, we have another right angle here. If we can find out the length, or the length of this side from here to here, call it y. What does that equal? And then if we could find the length from here to here, call it maybe z. If I could add y and z together, I would get the height of my tower. We could treat it as one angle, but we run into a problem because we need a right angle in order for our trig to work. Now, if we had one big triangle, as soon as we combine the far side, the big tower, we'd lose our right angles. So we couldn't actually calculate using trig. We could do other sort of calculations to figure it out, but we need to use trig. So let's look at the bottom triangle first, I guess. Maybe I'll just redraw it. I have the fact that this is 75 meters. I have 32 degrees, and I'm trying to find what I've called z. And then I have the top triangle here, where I have my right angle. I've called this y now. This is 75. And I have 40 degrees. So these are my two triangles. If I can find y and z, then I can add them together and I can go from there. So I'm just breaking it down. This is my opposite side. This is my adjacent side. This is my hypotenuse. I am trying to find the opposite. I have the adjacent, so SOHCAHTOA tells me to use the tangent is the opposite divided by the adjacent. In this case, I have 32 degrees. The opposite, calling z, 75. Then I will multiply both sides by 75 to get rid of it in the denominator. And I can plug it into my calculator to figure out what 75 times the tangent of 32 is. So 46.86. So that's the first part. The second part is the blue part here. This is the opposite side. This is the adjacent side. Again, I'm dealing with the tangent of my angle is the opposite divided by the adjacent. In this case, my angle is now 40 degrees. The opposite I'm calling y, and the adjacent is 75. The exact same process I just went through. Multiply both sides by 75. And I get 75 times the tangent, 40 degrees is y. So 62.93. Now I just need to add these things together. So I'm going to take this 46.86, which was the bottom triangle. I'm going to add to it this 62.93, and I'm going to get 109.79. I think these are all meters. Yes. 109 meters for the height of the opposite building. So again, this is kind of getting back to the question you asked earlier, Alex. Why would we care to use any of this right angle trig stuff? Well, if we couldn't physically climb the building, what we could do is go across, look at angle up, look at the angle down. We could measure how far the buildings are apart, and then we could calculate the height of it. So it's an indirect way of measuring the height of something. Another example, I have a garage that I built in my house. I was trying to calculate the surface area of the garage so I know how much paint to buy. And it has a vaulted ceiling. So now I have this triangle, and I started measuring and, doing trig, but my ceiling's 12, 15 feet high, so I couldn't get up there with a measuring tape, so I had to, use the angle of my roof and all this stuff, and go from there. Why do you need to know the height of a building? Alex, the question kind of implies that you know what you're going to be doing in 5 years. Maybe you're going to be a window washer in downtown Vancouver, and you need to come up with a quote as to how much it's going to cost to wash all of the windows on a building. Well, you need to know how high the building is. You need to know in terms of maybe safety, getting ropes that are long enough, calculating, how long it's going to take to do the building. You multiply the height by the width. All of a sudden, you don't know how high it is. I know. I try to make things make sense, Alex. Students always complain about math. When are we ever going to use this in our real lives? I'm going to tell you that you probably don't know what you're having for dinner on Sunday night, and you have no idea what you're going to be doing with your life. So implying that because today this doesn't seem important to you, it's never in your entire life going to be important is just kind of silly. You don't know where you're going to end up. Some of you have a really good idea of where you'd like to end up. It doesn't mean you're going to end up there. So when we teach math, we're teaching broad array of topics to cover as many possible sort of situations in life as we can. It's not necessarily about using the tangent and the cosine ratio. It's about allowing you to understand the process of what we're doing in math. So it's kind of one of these things. You don't know what you're going to be doing with your life, and maybe you're going to use it, maybe you'll never see it again, but you can't guarantee it either way. So I, in my everyday life, use trig. And I'm not just saying that to kind of like justify teaching it to you. I just do. It's just something I've used before to solve problems in my life. So, and maybe some of the other stuff like quadratic equations, you might not see a direct application of that, but maybe once you go on to math, you'll see how it applies to your life, things like that. So just consider that. It's 10:10. What I'm going to do is I'm going to give you guys 15 minutes. I'll give me a few minutes. I'm going to give you guys 15 minutes to go through the learning guide and just do a couple questions. And then if you have anything you'd like me to go through with you at the end of that 15 minutes, I'd be happy to do so. Basically, everything of the Unit 8 should be done now. I know we kind of did 2 small sections and now there's a bunch of questions there, but generally speaking, the questions don't take very long and they're all quite similar. So for page 7B, you can, for 7B, use the Pythagorean theorem if you want, or you can use trig. So you have the opposite and the adjacent, so you could use the cosine and sine ratios to find those 2 missing sides. Or once you find a second side, you can use the Pythagorean theorem to find the third. There's no rules. So we'll put 15 minutes on the clock. In 15 minutes, we'll come back, see where everyone's at. Try a few different types of questions. If you have anything that's pressing along the way, you can throw a question into chat as you go. Maybe somebody else will be able to help you out. So we'll see you guys in 15. Thanks.